Hope that all are doing well. Stay at home, stay safe. Already, other than the KV, for the other schools, we have started the class in February itself. And the first lesson, that is real numbers, only one topic is left out, that is revisiting rational numbers and their decimal expansions. Only that small topic is left out. Today I am thinking of taking a new lesson known as polynomials. And already you have studied the same lesson in 9th standard, polynomials. And this is the continuation of the 9th standard lesson. And before that, this year's I'll make you familiar with which all lessons we have to study this year. And as in the previous year, we have 15 lessons in 10th also. And only 2 lessons, that is the 5th and the 8th lesson, will be new for you. Means 5th lesson is arithmetic progressions known as AP, and the 8th lesson is introduction to trigonometry. Trigonometry will be a new topic for you, and the 9th lesson is its application. All other lessons are the continuation of 9th standard lessons. So you will find it so easy, interesting, and as I say, usually 10th standard lessons are more simpler than the 9th, and also will be very interesting, no doubt. And let's start the lesson, polynomials. Chapter 2. As you know, polynomials are algebraic expressions, and it may contain more than one variable. But last year you have studied polynomials in one variable, and excuse me, and we have seen that all the algebraic expressions are not polynomials. Certain conditions are to be applied to become an algebraic expression to be a polynomial. That is, the degree of the variable in the expression should be a non-negative integer. Means the degree should be a whole number. And also the coefficients of the terms should be any real number. Then we discussed in this lesson polynomials in one variable x, and its general form is given by p of x is equal to an x raised to n plus an minus 1 x raised to n minus 1 plus etc. plus a1x plus a0. This is the standard or the general form of a polynomial in one variable x with degree n, where we have to apply the condition where an or a1, a0, a1, a2, etc. an are real numbers. Okay, and we can classify the polynomials in 2 ways. One is based on the number of terms, which you have studied in earlier classes. And I think you have started studying algebra from 6th standard. And then itself, you might have studied the classification, depends on the number of terms of expressions. That is monomial, binomial, trinomial, etc. Quadrinomial, etc. And in general, we give the name polynomial. And here, this year, the classification we study not on the basis of the number of terms. Instead, it is on the basis of the degree of the polynomial. And what do you mean by the degree of a polynomial? You know that it is the highest degree of the variable in a polynomial. Is known as the degree of the polynomial. And we may call it as, if the degree of the polynomial is 1, we call that polynomial as a linear polynomial. And if the degree is 2, we call it as a quadratic polynomial. And if the degree is 3, it is called a cubic polynomial. And so on. Then, the next term, which you have already studied. What do you mean by the zero of a polynomial? What do you mean by the zero? And how to find the number of zeros of a polynomial? Okay, if you define the zero, let Px be a polynomial. Then a real number k. Let the polynomial be Px and we consider a real number k. Then we can call k, the real number k, as a zero of the polynomial Px if P of k equal to 0. This is the definition of zero of a polynomial. A real number k is called a zero of the polynomial Px if P of k equal to 0. Then this year our first topic is zeros, relationship between the zeros and the coefficients of polynomials. And the standard form or the general form of a linear polynomial is given by, as you know, it is ax plus b. P of x is equal to ax plus b is the standard form of a linear polynomial. And how to find the zero of this linear polynomial? For that, we have to make this linear polynomial as a linear equation. What do you mean by an equation? An equation is a statement of equality. Wherever we see this equality sign, and if an expression is equated to 0, it is called an equation. Then this linear polynomial, I have made it as a linear equation. Then we have to solve it. Ax plus b equal to 0, then we can write ax equal to minus b and x equal to minus b by a, which is known as the zero of this linear polynomial. That is, the zero of a linear polynomial in x, ax plus b, is given by minus b by a. And also we can say that a linear polynomial in one variable x has a unique zero. Unique means one and only one. Only one zero it has. And it is given by x equal to minus b by a. Then next is, what is the relationship between this zero and the coefficient of this linear polynomial? That is, minus b by a means the zero 0 is given by minus of, here C, B means it is the constant term, then minus of the constant term divided by, it is, A means it is the coefficient of x, it is the coefficient of x, and this is the relationship between the 0 and the coefficient. The 0 is itself in terms of the coefficient, that we can see here. And I think you might have understood. And okay, I'll give an example for this. Find the 0 of the linear polynomial 2x plus 3. Then first of all, solution. We have to give names for the given polynomial as p of x, since the variable here is x. Then let px is equal to 2x plus 3. Then as I have told you, we have to solve this. We equate this linear polynomial to 0. 2x plus 3 equal to 0, we get 2x equal to minus 3 or x equal to minus 3 by 2. This is the 0 of the linear polynomial 2x plus 3. Then how to verify this and the coefficient? That is, here it is equal to minus 3 means minus of the constant term. Is it? Minus b by a. This is of the form ax plus b. Hence verified. And your question will be like this. Find the 0 and verify the relationship between the 0 and the coefficients. And this is about a linear polynomial. Next we consider a quadratic polynomial. Okay, and as you know, a quadratic polynomial is a polynomial with degree 2, and its general form is given by ax square plus bx plus c. We can name the polynomial index as p of x. Then bx equal to ax square plus bx plus c is the general form of a quadratic polynomial in variable x. Here the highest degree of this polynomial is 2. That's why it is called a quadratic polynomial. Then where, and the condition also to be applied, where a not equal to 0, a, b, c are real numbers. The condition is compulsory. A not equal to 0. If a becomes 0, the degree of this polynomial won't be 2. This whole term will become 0. That's why the first coefficient should not be 0. And the first coefficient should not be 0, but all the other may be any real number. And depends on the degree of the polynomial, how many zeros are there as maximum. Maximum number of zeros only we can say that. The maximum number of zeros are 2. Since the highest degree is 2 here. And we name, let us name the two zeros as alpha and beta. Then how to find the zeros of a quadratic polynomial? You have studied last year that how to factorize a quadratic polynomial. What are the methods you have studied? Yes, using identities. Using identities means you might have studied almost more than 10-11 identities last year. And since it is a quadratic polynomial, we can use any of the first 4 identities to factorize middle term method for factorizing these quadratic polynomials. And we name the two zeros as alpha and beta, which are Greek alphabets. Since already we have used these English alphabets for these, and in order to avoid the confusion, we use alpha and beta for the zeros. And here the how to find alpha and beta already I have explained. We can use identities to factorize this and find zeros. For that we equate this given as usual. We equate this given quadratic polynomial to 0. Then we factorize it by using the identities or by splitting the middle term. Then each factor, we know that a quadratic polynomial has two linear factors. Then we factorize this into two linear factors and we equate this to 0. And after that individually we equate this with 0. We get the zeros. The two zeros are obtained by this method. And let the zeros be alpha and beta. Then what is the relationship between the zeros and the coefficients? It is not like linear. In the linear polynomial we got it has a unique zero and the zero itself is in terms of the coefficients. But here the zeros has no direct relationship between the coefficients. And the relationship here is given by the sum of zeros. Sum of zeros. If the zeros are alpha and beta, sum of zeros we can write as alpha plus beta. Then we can see that alpha plus beta in terms of the coefficients will be minus b by a. This is the relationship between the zeros and the coefficients. Then product of zeros. Product of zeros given by alpha beta. Alpha into beta, alpha beta. And it is given in terms of the coefficients as c by a. And this is the relationship between the two zeros of a quadratic polynomial and their coefficients. That is, if alpha and beta are the two zeros of a quadratic polynomial, then the sum of zeros, alpha plus beta is given by minus b by a and alpha beta is given by c by a. Then let's have an example. Consider the quadratic polynomial 2x square minus 8x plus 6. This is a quadratic polynomial in one variable x. Then we are going to solve this solution. The question is find the zeros of this quadratic polynomial and verify the relationship between the zeros and the coefficients. Then first of all, we are going to factorize it for finding the zeros. Then we write this. Let Px is equal to the given polynomial. Then we are going to factorize this given polynomial by splitting the middle term method. And what do we mean by splitting the middle term method? It is, we have to consider the middle term of this quadratic polynomial which is given here by minus 8x. Then the middle term coefficient here is minus 8. Then we should find two integers such that their sum is minus 8 and their product is 8c. This is of the form ax square plus bx plus c. have to find two integers such that their sum is -8 and their product is 2 into 6. Then we find sum should be -8 and product should be 2 into 6. 2 into 6 is equal to 12. It will be very interesting to find the integers. Sum -8 and product plus 12. And first of all, we have to use our common sense to find the sign of the integers which we are going to find out. Here, the sum is negative and the product is positive, and we have to find the two integers. We know that if the product is positive, there are two ways. First is both should be negative or both should be positive, and only we get a positive product. But see, the sum here is negative. Then no doubt that what we are going to find out, that both the integers are negative. Then which one are the integers? When we add, we get -8, and when we multiply, we get +12. It is okay. It is -2 and -6. Then we found the numbers. The integers are -2 and -6, such that their sum is -8 and their product is +12. So our next step is we have to use these two integers to split this middle term -8. We have to use these two integers to split the middle term, that is 2x squared. For -8x we use -2x -6x. Then the constant +6 is equal to 0. Okay, already using these two integers, we have splitted the middle term -8x as -2x -6x. Then we know how to factorize this type of expression. You have studied this in 8th standard. Here there are 1, 2, 3, 4 terms. Then how to factorize that expression with the 4 terms? We have to use the regrouping method. Regrouping 2, 2. First group, second group. Then first group is 2x square minus 2x. From the first group, we have to take a common factor outside. Both from the coefficient part and the variable part. From both we have to take a common factor outside. Then from 2x square and 2x, what is common? Common means it should be the HCF, highest common factor. It is 2x, no doubt. From 2x square and 2x, we take 2x outside. Then from 2x square, if we take 2x outside, there remains x. And outside means actually we are doing division. From 2x, if you take the same 2x, we get 1. 2x divided by 2x, we get 1. And from 6x and 6, 6x and 6, what is common? It is 6. Then -6. From 6x, if you take 6 outside, there remains x. And be careful about the sign. From this -6x, we have taken -6 outside. So x remains. And from +6, we have taken -6 outside. Then there remains -1. Because again, if we use the distributive property, -6 into x is -6x. -6 into -1 is +6. It's okay. Then we see x -1 is common in both. So we take x -1 as a common factor, and here remains 2x and here remains -6. And this is the factorization of the given polynomial, what? 2x square minus 8x plus 6. And our question is not to factorize. Instead, we have to find the zeros and verify the relationship. And we are going to find the zeros of this polynomial. For that, each of this x minus 1 into 2x minus 6 be equal to this to 0. This polynomial has converted into an equation. Then each of the linear factors we equate to 0. When x minus 1 equal to 0, we get x equal to 0. When 2x minus 6 equal to 0, we get 2x equal to 6 and x equal to 6 by 2, which is equal to 3. And we got the two zeros as 1 and 2. Okay, then the first part of this question is over. That is to find the zeros. Then we consider, let alpha is equal to 1 and beta is equal to 3. First 0, second 0. Next we are going to find the sum of zeros. Alpha plus beta is equal to 1 plus 3 is equal to 4. Then what was our polynomial? Our polynomial px was 2x square minus 8x plus 6. Is it? This was our given polynomial. And here when we is of the form general form ax square plus bx plus c, where what is a here? A is equal to 2, b is equal to minus 8 and c is equal to 6. Then what we get as minus b by a? Okay, let it be there and we will find it. We got already alpha plus beta as 4, and how to relate this in terms of the coefficient. Whether this is equal to minus of minus 8 by 2, minus b is minus 8, then minus b will be 8 by 2 is equal to this. We get it correct, is equal to minus b by a. The first part is verified. And alpha beta, we find alpha beta. Alpha beta is equal to 1 into 3 is equal to 3. And what is the relationship between the product of zeros and the coefficients? See, it is equal to 6 by 2. We get c as 6 and a as 2 is equal to 7. And we got it correct. We got the zeros of this quadratic polynomial by factorization method. By factorization method means we have used it here, the splitting the middle term method. And we got the two zeros, alpha and beta here, and we have verified the relationship between the zeros and the coefficients. And this will be the type of question asked for the exams. The polynomials will be given, will be asked to find the zeros and to verify the relationship between the zeros and the coefficients. And one more type of question, that is, you will be given the sum and product and how to form a polynomial from that, the reverse question. Okay, let's discuss with an example. And I am going to give you, there are two methods, and for any question you can use alternate methods also, and it should be explained well, that's all. And there are two methods to find the polynomial given the sum and product of zeros. And here I am giving only one method in order to avoid confusion, since you are studying by yourself from home, and I will explain the other method from the class later. And listen, given the sum and product of zeros, given the sum and product of zeros, how to form a quadratic polynomial. That is, given alpha plus beta and alpha beta. The polynomial means the quadratic polynomial. The quadratic polynomial is given by, the degree is 2, x square minus sum of zeros into x plus product of zeros. This is the method. This is the easiest method. If the sum and product of the zeros are given, directly we can form the quadratic polynomial by substituting in this form. That is, x square minus sum of zeros into x plus product of zeros. In other way, we can write it as x square minus sum is alpha plus beta into x plus alpha beta. This is the reverse question. First question was to find the zeros and to verify the relationship between the zeros and the coefficients. And this one is, given the sum and product of zeros, you have to form the polynomial. Okay, and I give an example on this. The question is, find a quadratic polynomial whose sum and product of its zeros are minus 3 and 2 respectively. Find a quadratic polynomial. Find a quadratic polynomial whose sum and product of its zeros are minus 3 and 2. Then respectively, that you should listen carefully. Sum and product are respectively. Then the first number you should take as the sum and the second one as the product. And in order to confuse you, sometimes it will be given product and sum are respectively. Then you have to read it very carefully. Sum minus 3 and product. This is the question. Then we start. Solution. Given alpha plus beta is equal to minus 3 and alpha beta is equal to 2. Then the polynomial is x square minus alpha plus beta into x plus alpha beta. This is the format. Then for alpha plus beta we have to substitute this, and for alpha beta we have to substitute this number. Therefore the polynomial we get it easily. X square minus is in the format. Then minus of minus 3 into x plus 2. Minus of minus 3 will become plus 3x plus 2. And this is the required polynomial given the sum of the zeros and the product of the zeros are given. I think it is easy. And this is about exercise 2.2. What you have to do is you just try this exercise 2.2 as homework. Exercise 2.2. And if you have any doubt, you may ask through the WhatsApp. Okay, and do this. And you'll be thinking why exercise 2.1 is not discussed. That is about the geometrical meaning of the zeros of polynomials. And geometrical meaning means it is the graphical representation. It is not from the examination point of view. You won't be asked to draw graphically the polynomials. The question will be only 1 mark question, that is just to find the number of zeros, and number of zeros from a graph depends on at how many points the graph cuts the x-axis. That's all. And in exercise 2.1 you just observe, that is just a knowledge level question. You just observe the graphs given in exercise 2.1 and you see these graphs. There are 6 questions given. You see these graphs and each of them, at how many points these graphs cut the x-axis only. For example, I'll just say the first question. With this video, you take your NCERT textbook also with you while you watch this video. Then the first question we see that no points. At no points the graph cuts the x-axis. And the second question we see only at 1 point the graph cuts the x-axis. So the answer for the first question is 0. Number of zeros 0. And the second question is the number of zeros is equal to 1. And so on. You just try it. And you may do the second exercise, that is exercise 2.2. And the first question is to find the zeros and verify the relationship between the zeros and the coefficients. And the second question is to find the quadratic polynomial given the sum and product of its zeros. And if you have any doubt regarding this, will be explained again. Don't worry. And thank you.